these give us 20 gigabytes. But because these are mirrored, we only get 20 usable gigabytes out of the four hard drives. Again, that's very redundant because we have 2 exact copies of all the data. But given 4 hard drives, that's not as efficient as the RAID 5 set was. The performance levels are really going to depend on the hardware you're running on, the operating system you're running on, whether you're using IDE drives or SCSI drives, or 10,000 RPM or 15,000 RPM drives, whether you're using SCSI 1, 2, 3, Ultra, 160. There's what level of caching is on your hardware controller or the disk drives.
The 2.4 kernel now supports SCSI tag
queuing.
command queuing, which is supposed to be an enormous performance boost, but it has to be supported by your hard drive and your controller. I don't think it's enabled by default. So if you've got like Adaptec controllers and Seagate disk drives, I think you might want to look into that. And it should be just a little proc file system option. You just cat 1 into some kernel option inside the proc file system, and that basically turns it on. And then you get big time performance gains, especially because what happens now is that your SCSI hardware, your SCSI chips are allowed to basically queue up a ton of commands and send them across the bus in one shot, and then the disk basically, kind of like, I don't know, it's like this fast. Okay. Gordon, the question is, what RAID levels do the RAID tool support?
The linear, which is just the concatenation, 0, which is the striping, 1, the mirroring, 4, and 5. Almost all of the RAID levels that are out in use today. Just for those of you who are curious, there are RAID levels 2 and 3. 2 is a very low-level checksum sort of computation that required an extraordinary number of drives and a very complex controller that really didn't give you any significant benefits compared to RAID 4 or especially 5. I forget the details of RAID 3.
They're not important.
But yeah, it was not important enough to make it a worthwhile RAID set. RAID 6, if I remember right, is RAID 5 with an additional set of parity checksums so that you now can withstand 2 hard drives failing in the same RAID set.
Is that considered 5E or
it could be. Yeah.
I don't understand the difference between striping and linear. It sounds like in both cases you're just writing across drive.
Not quite. With striping, you're actually alternating your writes between the hard drives. So that if you're writing a lot of data at one time, you're writing one chunk to the first drive, while that's often going, you're writing the second chunk to the second drive, getting much better performance. Linear is simply concatenating, where you write serially onto the first drive until it fills up, and then you start writing on the second hard drive.
So linear doesn't speed anything up, but it just lets you put something bigger on a small.
It lets you create larger file systems.
Right.
If you've got 2 gig drives, you can create a 4 gig drive and then basically mount it to the big 4 gig drive.
And also is that the linear allows you to have different hard drive sizes.
Yeah, it allows you to mix and match hard drive sizes. If you got 2 or 3 1 gig drives from the dump, a couple of 500 gig drives from the dump, you can combine them all to create your 750.
You have to show us where this dump is.
It's an ongoing process. Just take your recyclables to the dump instead of putting it on the curb. You tend to find a bunch of junk that way.
The Linux RAID also supports the concept of a spare drive, which is a hard drive that's just sitting there idle, unused, and is ready in case one of the other drives fails when you're using RAID levels 1, 4, or 5. Anywhere you have redundancy in your RAID setup, a spare disk will kick in if one of them fails. So when you're using the RAID level 0 or the linear, you have no redundancy, so if one drive fails, there's no way to recreate that data. So having a spare doesn't do any good. Yeah.
So 0 is just buying you performance, there's no extra.
Zero gives you performance and gives you that sort of abstraction where, again, the two 2 gig drives could be made to look like one 4 gig file system.
There's no redundancy.
No redundancy at all. No.
The Linux mirroring system file is also mirrored.
It can boot from either disk.
Yeah.
Basically, we'll test this in just a minute, hopefully. What I want to do is, as soon as he's done, is I'm going to turn the power off on this disk. And hopefully the system will stay there. And then we'll reboot the box and watch it boot from the other disk. What happens is that Lilo has to get some extra configuration information. And basically, you're going to configure Lilo to look at the meta device, the MD device. If you look at the little DF-K, you'll see my devices that are no longer dev, HDA, or SE, or whatever. They're usual MD numbers. That's a meta device. And that's basically another abstracted layer from the kernel. The kernel doesn't see both devices. It's basically the device driver that knows how to communicate. So when the disk boots,
Here's a couple of the lines from the lilo.conf file where you specify that your boot file system is in fact dev MD3 or whatever meta device your boot file system is. Yeah, there you go. Yeah. Fourth line from the top, boot equals dev MD0. And these were set up in that Kickstart config file. I actually specified what MD devices to use. As you're going through a regular Red Hat manual install, you can tell it to set up a partition and make it a RAID partition, set up another one, make it a RAID partition, and then set up a file system on that RAID pair. And it will assign an MD or meta device number to it.
are we ready? Should we go do this? Sure. Or there's something else I want to talk about first. This is like the end all of yay, no, and then everybody claps and cheers. Is there anything else you want to talk about?
Go to another person console and do a tail on the messages.
That's what I'm doing right here.
Oh, okay.
It's the tail of the messages.
All right. Make it so.
What's the RAID tab?
The RAID tab file is a configuration file that tells what RAID devices you have, how they're laid out on what actual physical partitions, what RAID level you're using. Go ahead and go to the SE directory and do a more on it.
For those familiar with the Sun Solaris ODS product, this is similar to the md.tab file for the Solaris stuff.
So Lilo must read that RAID tab file.
No. Yeah. I don't know.
Somehow it has to know where to
The
find
boot
your...
kernel is RAID aware. It knows what meta devices are and how to talk to them.
But that's really like
right, but
that
Lilo is going to... No, Lilo just points to the device, the MD0.
Right, somehow it has to know how to get what MD0 is made out of.
No, all it cares is that the boot device is MD0, and then the kernel takes it over from there. Because MD0 has a major minor number, knows what device, what modules.
Exactly.
I'm not sure about this, but I think when you make a RAID device, it actually writes a header at the beginning of the partition of each of the different partitions of the different drives, and the kernel driver itself reads that information off the disk. It tells the kernel driver how the disks are all laid out. So it's not in a file. I mean, it is in a file. You're looking at it there, but I think it's also the kernel without being a file system.
Right. In the Veritas world, this is called the VTOP. And basically, it's a little partition on the disk that preserves information about all the other disks in the system so that when the system boots up, it can look at any VTOP on the box, basically, figure out what's going on in all the disks. In the Sun world, they call that the, what the hell is that command do? You create these little DBs, little databases on the disk, and you're supposed to have multiple databases for all your...
ODS?
Yeah.
MetaDB?
The MetaDB, that's what it is. It's the little meta device database, yeah.
Part of the way down there, one of the options is persistent superblock, which is an almost given in the RAID set today. That tells the RAID tools to write a superblock on each disk in the array so that any one of them has all of the information about all of the drives in that RAID set. So that when the system's coming up, it can look at any superblock in the RAID set and sort of auto-discover what the whole RAID set is supposed to look like.
Okay, let's do this. Okay. All right. Little do they know, when they sold me these things, they said, oh, it has keys to prevent you from removing the disk while the system is live. Little do they know what that means about that plan. I mean, Mark, it's that.
Die. On the next right.
Yeah.
Okay, it's up.
Do a right temp or something.
Moving Proc
Let's just read from dev MD0. How about that? dd in file equals /dev /md0. Please redirect to /dev. No.
Okay, that works.
Redirect.
That works.
Yeah. Either one.
Either one.
I'm sorry, I'm old-fashioned.
I wanted to use some kernel threading.
Count equals something.
Go.
Otherwise, you're gonna take forever.
Okay. HDA timeout waiting for DMA. Is it actually reading? Okay. Okay, it's determining now that there's a failure. Well, now go to a third window or go to this one in the proc file system. There's an MD stat.
Unless it system timing. It determines that the.
Yeah, it's got to wait for this to determine and take the device out of
It's
it.
going to take a long time.
Should have HD farmed it to not use DMA.
You're up now.
Well, we'll see what happens. All right, we'll leave it here. Let it time out.
This is the bad present for SCSI.
Reboot it while rebooting and pull one of the drives.
The one that's off.
14 bucks. I didn't find these at the dump. I actually bought these. The trays. Yeah. It's not bad. It's a little plastic box. Some of the better ones are made out of aluminum. What'd you do? Reset. Oh, it's just sitting there hanging. No telling how long it's going to hang.
We want to let it hang.
We want it to come back up and show that it can come back up.
Oh, we want to watch it reboot back.
Drive. We did format these with the ext3, so we shouldn't have to watch FSTK run.
Fail. Your boot sector lost. I think you're.
That's true. I think they're host.
So move the drive.
Okay, so move that one up.
Yeah, move the other drive.
Move it into the first drive.
Turn on the power.
All the little things we didn't think of.
I bet you Lilo now is installed that drive. Installed the other drive.
The BIOS probably isn't capable of doing
Actually,
anything.
Lilo should be installed on both of the drives.
Actually, you could probably change it in the file.
Probably could have.
Okay, yeah.
Probably the easier solution.
Well,
Of course, not there.
having these little quick swap trays, actually swapping the tray was probably the quicker solution given these files. Okay, so our process for enterprise grade was to contact the hardware management guy, have him walk out to the box and move the disk around. We have a process, so that's not going to start. Right.
Yeah.
So it goes
Not
right to the second disk.
It knows that the mirror is gone.
Now, let's say you get another hard drive from the dump.
Back in, there's a RAID automatic.
I moved to another town, my dump's not as good. You can see the boot recovering journal message there, so it did recover the journal transactions that were not
Does
committed.
the RAID from the drive that is now running, will that automatically start writing?
You need RAID
the second drive?
No, it's not automatic. I think there's some RAID commands. There's a RAID tool, and then you basically can do some. There's some level of automation. Haven't played with it yet, but in one of the last couple of versions of the RAID, there is a hot swap type command that will let you tell a live running system that you have a new drive to replace a dead one, and to go use that drive and run those partitions on that drive to synchronize the good data backup.
Are these drives plugged into a RAID controller or just a regular IDE?
This is regular IDE stuff.
Plain old-
And
well,
let me make
that's
the following
right.
point.
Primary and secondary IDE
My
controllers.
entire experience is based on SCSI hardware.
Right.
We pull a disk from the SCSI environment, boom, that message pops, system
Right.
just keeps right on going. I don't know what this particular hardware is doing. Maybe there's something in the BIOS I can change.
2.5S things that I can alter, you know, to basically prevent it from hanging when the bus gets locked.
From what I've read, it won't